Okay, Matt. I'm trying to do our L'Hopital's rule with f and g going to infinity. How do I explain this? So the red curve here is a parameterized curve. So g of t, f of t, that represents x and y. Here's a line going from 0 to g of t, f of t. So the slope is rise over run, which is f of t over g of t. And the point is, if we start moving this out to infinity, okay, the slope can change quite a lot. And now what I've done is I said, okay, let's add a point, evaluate the function, add a point on the curve, and another point on the curve. And this gives us a little, it's essentially a secant line. And the point of the secant line is, by Cauchy mean values theorem, there's a point on the curve where the derivative is equal to the slope of that. So the slope of these little peaks line up with the slope of this. So the point is that you don't have to look at the slopes back here. You can look at the slopes further on in the curve. And then as we go out to infinity, even though these things move a lot, as you get further and further out to infinity, these two lines, the secant line and the sort of tangent line, they end up being essentially parallel. And that's kind of the point. So as you wiggle out to here, these two lines, the f over g curve and the f prime, the slope of the secant line, they're basically the same. And from Cauchy mean values theorem, this little secant one is going to be parallel to an f prime over g prime. So that's what we're trying to get at. I'm not sure that I can do that easily with string and cardboard. I've got the string and cardboard done, but it's actually hard to move around. So.